My name is David Lockett. I'm with Crestron Electronics. I started with Crestron about a year and a half, almost 2 years ago now. Before that, I was in the consultant world. I spent time at Arup and Affiliated Engineers out of LA and Seattle, respectively. But before that, I did spend a good 5 years of my life at Pepperdine, at USC, down in Southern California, as well as a couple other like ad hoc library design, things like that. So I've been around the world of AV for a while, and the university setting in particular. Small group, how many of you guys are familiar with the engineering behind a USB? How much do you guys know? Let's just take a quick poll. Could you tell me what the pins are? Could you tell me about tiers, anything like that? Okay, no, great. So this will be a great class for you, I hope. But let's go ahead and dig in. So we'll start just initially. Actually, let me do one thing here. I needed to go into presenter mode. Show. Okay, where's my presenter? I did just get surgery on my eyes, so I can't see my. No, I'm looking for presenter mode. Yeah, switch show presenter. There we go. Okay. And that is good. So let's just go over here. So I did just get surgery on my eyes, so things are a little bit funny. But anyway, so this class is essentially an evolution of our Understanding USB class, which for those of you that have access to our support knowledge base, and if you don't, go talk to Don out at our table out there. He'll get you access to that, and you'll be able to download or click on the link or go to the webpage that's associated with. But this is an evolution of that class that we taught at Masters for the past in 2022, 2023, and then we evolved it a little bit, and I taught it just last week down in Florida. So my version was more dealing with data, but this we're going to step back and go more broad and then touch on some things. And there's just a lot to cover. My class alone, which again was just a small subset of it, was an hour and a half long. So we've got 45 minutes today, so we're just going to really hit the high points here. But if there's something that you aren't clear on, or you're like, that doesn't make sense, or somebody told me something different, come see me afterwards, and let's sit at the table and have a discussion. Okay, so we're going to talk first. We're going to go over some of the connectors. You guys, this seems maybe very basic, but we're going to get into it a little bit. And then we'll talk about how the power side of things work on USB. And then we're going to talk about USB data and what's actually happening there. We're not really going to go deep on that at all. But then we're going to talk about tiers, because this is the thing that causes the most headaches for people. But before that, we'll just do a quick history. USB was initially developed as a sort of a consortium back in 1995. Before that, I don't know, anybody remember how to connect a printer before USB? Parallel, yeah, and Apple had a different one that they did on their own. You could do it with SCSI if you wanted to, but there were a lot of different configurations. You had to know what you were getting. It was a complicated thing and very frustrating. So that kind of thing, that idea of peripherals, they wanted to be able to make it more standard so that they could all play on the same field and sell more of their own boxes. But essentially, that's just a real quick thing. I've thrown it up here. I don't want to spend a lot of time on it, but you can see back in '95, that was when the original release candidate came out, and then the initial 1.0 came out in January of 1996 at a whopping 12 megabits. Not a whole lot. Now, obviously, I don't know if you guys are aware, but USB 4 the spec was released in 2019. How many USB 4 ports are there? None, because Microsoft just updated release. Microsoft just issued their first release that will actually support USB 4 just 3 weeks ago. Hey, how you doing?
Good, how are you?
Good to see you. Just 3 weeks ago. So for those of you who are wondering about that, yeah, you might start to see some of that come out, some USB 4 stuff come out, but I wouldn't really expect to see it a whole lot in our world. Just know that it's out there. So, as I said, we're going to start talking about the connector. So, we all know these, right? What's this one? What kind of, what standard spec is it? 2.0. 2.0. How about this one? 3.0. 2.0, 3.0A. What about that one?
2.0A.
Yep, exactly. And this one? This one's a little tricky. Anybody got a guess?
3.0 mini.
3.0 micro, right? Because it's the same as your USB-B micro that they used to have, but there's your extra 5 pins. There's your B 3.0, and of course our USB-C. So anybody know what the colors of the block means? Anybody got a guess?
Blue means it's 3.
That's right. What about the white?
Not
2.0. That's right. This one's a bit funny because it doesn't have the blue, but it is 3.2 capable, or 3.0 capable, or USB 3 capable. So looking at the original USB 2 spec, it had 4 pins, right? It had your 5 volts data, your data 1, your data 2, and your ground. I think it's actually the other way. 5 volts, data 1, data 2, or data plus, data minus, and ground. So again, we've essentially got a twisted pair in there. That's all we're doing, and we're carrying the 5 volts on that first pin. What we see when we stepped into USB 3 is there are now, how many pins? Anybody know? Obviously we can count, but anybody know off the top of their head? There are 9 pins. It's the same 4 pins that were in USB 2.0, and we've got 5 more pins in the back there, right? So that's why when you see the B cable on the USB 3.0, there's actually 5 pins there as well. It's the same 5 pins that are back here, and on that micro one we saw on the first slide, there were 5 pins off to the left, right? So what is important to know about this, and I know this may seem a bit like pedantic, and I apologize for that, but I want to make sure and draw attention. This is a USB 3.0 spec, but look here. So when you connect a USB 2 device to a USB 3 port, will it work? Yeah, because those pins are just carried in. So that's your basic USB data path, right? And it is carried forward into the USB 3. It's the same pins. So when you connect it, it's the same pins. They marry right up, and so it'll work. So you could even just throw an adapter onto this cable and it would work. What do we get with USB 3? How is it better? Well, we've added another pair of 2 more differential pairs, so a receiver and a transmitter. So this is how we get our high-speed data, right? And what, generally speaking, data rates are we talking about when we're talking about USB 3? There's 3.0, 3.1, 3.2.
40 megs?
40 megs? No. USB 2 is 480. We'll talk about that later, but I just want to briefly, again, that's kind of a gauge of where we're at with the room here. So the point is this will carry the same 480 megabits on those 2 pins, but because we have these 2 extra differential high-speed paths, we are now able to get up to 10 megabits depending on how, or 10 gigabits depending on how you encode, right? What the device is actually doing to encode it. And we're not going to get into encoding. Question?
Curious, does it use the 2.0 pair when you're doing full?
It does. That's how it gets its first 480 megabits of data bandwidth. So anyway, but that's actually the point I'm trying to make, so I'm glad you caught it. We are actually stacking, and that's how we're getting those pathways in. So USB-C. So I asked the question about the other connector. What data rate or is associated with USB-C? Who knows? Or who can tell me?
Depends on the cable.
It depends on the cable. It's a trick question, right? So we know that USB-B and the A, those are connected with like the white and the blue. They're associated with a standard spec, right? A 3.0 or a 2.0, right? But USB-C, it's just a connector, right? You could use it for USB 3, you could use it for USB 2, you can use it for power. In fact, you can buy some of them these days. They don't even have any of the data pins on it. They just have power pins, right? That's how many of our, my laptop is charged with the USB-C connector, right? So we're doing power delivery on that. Now, I don't have time really today to get into it, and so I will just touch on power more related to peripherals than about actually using power delivery. But anybody know, and again, this is something we'll talk about later, but anybody know how we're able to do that with USB-C? How we're able to use it for power delivery when on USB 2.0 we had 5 volt pin. How do we get a 5 volt pin? It's only carrying a half an amp. How do we get from that to a full 100 watts of power, right? Anybody know how we do it? But what we've added to USB-C that USB 3 doesn't even have? Or the old USB 3 cables don't have? Well, it is this extra lane of power. And in fact, I'll show you another one here in just a minute, but before I do, I'll just touch on the rest of it. So you can see in this chart here, we've got these check marks. They're basically saying these pins are associated with any of our USB 2.0 pins, right? So here again, just like we talked about before, here's our unshielded twisted pair, right? That is our original USB 2.0 pair, and it's still there in USB-C. Now, there's the differential pair 1 and 2. That's the one from USB 3, right? So it's there in your USB-C as well. And then we've added another pair, a set of pairs, right? Differential pairs. So that's our high-speed bandwidth. So when we actually do DisplayPort alt mode, that's where we're going to see that. Other things to talk about is we do have this VCon pin, and we've got that second lane of power, right? And then there is this extra ground pin. That's for the shielding that's around all of these guys. They all connect to that drain pin for the differential pairs. So this is getting, I understand why we're talking about design. Why are we talking about pinouts on cables? Well, it's just to understand, because as you're designing these things, you need to think about what you're putting into the cable and what kind of connectors you're using. And most importantly, and I'm not going to get into it, but you need to pay attention to the spec of the cable you actually provide, right? So have anybody seen that Mythbusters thing where they actually did the x-rays of the USB cables? You guys, anybody else seen that? You should look it up. It's very interesting, right? There's the $130 cable, right? That's the made for Apple, works with Apple kind of thing. And then they go through and they kind of x-ray everything down from the $150 version all the way down to the $3 cable. And it's pretty interesting to see what they're actually changing and doing inside of the cable, right? So that is a design challenge and a question. You don't just want to go buy the $5 thing on Amazon. It is actually a different cable. So just, again, as you're designing, think about that. Breaking, so how many, everybody knows the joke, how many times do you have to try a USB before it plugs in, right? Right? There's the first way, then there's upside down, and then you go back to the first way, right? 3. So USB-C does get rid of that. Anybody from this picture that knows how we're able to do that? Like USB-C, it's reversible. It'll go either way. You only have to try it one time. Anybody see from this how we're able to do that? Right? Yeah, because if you put it in this way, like with the top up like this, right, you're using these channels and these channels, right? But then when you flip it, you're using these channels and these channels, right? So you've essentially just reversed it. So that's how it's able to work. But the way it does that is it actually has this CC1 and the CC2 cable. That's how it identifies the directionality of the cable. And then it says, okay, well, this is going to be my A1 and this one's going to be my B1, right? That's how it actually does it. There's a pair of pins in there that are, their sole purpose is to tell the spec or the host controller, hey, I'm this way or I'm this way, right? So that's how it identifies, again, our DisplayPort alt mode path, right, which is here on pins A10 and A11, right? And you know, when you flip it, they show up down on B11 and B10. And then how we have our high-speed path. Now, there's another thing about this drawing that I want to draw attention to. So we know that in USB 2.0 pins, the first pin was power, right? And we know that in USB 3, that same pin is carrying power. It's got more amperage on it, but it's the same pin out, right? We're not adding an extra voltage pin. In USB-C, we do add a second lane, right? So here's our V bus and here's our V bus, right? So when we flip it, it's the other way around, right? But power isn't quite the same thing, right, as data, right? Because power is just power. So how we're actually able to get up is not just the addition of a second lane, but it's also, hey, look, we're flipped. This is still just a voltage bus. It's the same voltage bus. So we've actually got 4 lanes of power that we can draw on, although typically that's only reserved for your power delivery cables, right? So they're the ones that are going to use all 4 lanes of that. But they are there, and when you do connect into a port, you could theoretically power. That's how most of our charging devices are working. They're plugging in and getting power down all 4 lanes, despite your inversion, because it doesn't care. Your voltage is there regardless. So, okay, yeah.
Doing that 4 different lanes just because of the amount of actual copper in the cable, or is it? Are you doing? Or is each one of those lanes powering some other part of the?
No, they're all just showing up at the receiving end, at the host end, right? It's all just showing up there. So you've got 5 volts of power here, you got 5 volts of power here, you got 5 volts of power here, 5 volts. Yeah, it's just adding up, right? So you're just getting up to 20 volts. And some of the PD, there is actually a USB power delivery spec now. So and for those that meet that spec, they actually do increase the voltage on those because they're for power delivery. Again, you have to pay attention, and in fact, if you so I showed you the QR code for Ken's class, which I'm adapting here at Masters. When we do release our Masters videos for this year, Joe, my partner down in Southern California, some of you may know him, Joe Hernandez, his class, he breaks down USB fully and goes into all of these things and explains how this works. And he's got a slide that just shows you all the various specifications of USB-C and how it all is muddy and just very confusing. But there's a whole bunch out there, and they're all standards, and there's like 8 of them, right? So anyway, moving on, and this all we're really talking about here is the fact that even with our USB-C connector carrying USB 3, that connector is used for Thunderbolt 2, right? And we know that not necessarily every USB-C cable will support 40 gigabits, although that is the spec for USB 4, and it is going to use a USB-C connector, at least for now it is. And I don't see why we would change that, especially with all the legislation going on around that in the EU as well as in California. But yeah, it'd be nice if we had one spec that cable was that, but we don't. So we're going to have to guess. And again, as designers, this is something you're going to need to pay attention to. Don't look at that port on there and say, that's USB-C, I can use that and work with that. It's going to have DisplayPort alt mode on it. Don't do that, right? That's a mistake. You could get to your field install and be like, wait a minute, it's just USB data only, and I can't get my video in there. So that's kind of talking about the connectors. Before we dive in, covered a little bit of info there. Do we have any questions on any of that? Can I dig in any further, or things that you really that didn't make sense or you felt like needed more clarity?
I got this is probably my first mistake. I got a USB-C cable from Amazon, and the manufacturer swore on a stack of Bibles that this is totally going to work for any application. It's a great cable. You should totally buy it. And when it came in the mail, there was a little tag on it that says, "Oh, by the way, when you plug it in, if your stuff doesn't work, unplug it, flip it over, and plug it back in."
Which shouldn't work. Shouldn't matter, right? Because we've got our pins switched.
What the hell?
Well, if you're buying, I had a comment in my presentation where I'll just make the comment. It's like, if you're buying it on Amazon and the Google Translate looks like a Google Translate document, maybe don't risk it. I can't help you with your problem, but that's where it kind of comes in. Just say, make sure you're buying from a reputable source, because it is the Wild West. The specification for the cable does say some things, but there's so many out there, it's just easy to fly under the radar.
So
right?
what should you be looking for when you're actually...
Just a formally published spec, ideally from a reputable organization. Like when we have our USB 3 cables, they're on our website. We can go look at them. I have one out in my bag out there. I can show it to you. But we have a full published spec on what's going on with it. We don't tell you what's happening on all the pins, but we do give you like, this will do this, it will do this, it won't do that kind of thing. So, yeah, you can't know, and I can't tell you how to find out, because unfortunately there's not a required, the spec doesn't tell you how to do it.
Okay.
So, at least not at this point.
Thank you.
No problem. So shifting gears, and let's talk about power. So this one, there's a lot more I could say here, but I'm gonna breeze through it. So power, how does a USB device get its power from the host, right? So first off, let's talk about what the specs allow. So for USB 2, we've got 2.5 watts, that's 5 volts on that one pin, right? And it'll carry a max of 500 milliamps. So that's the most of power that you can draw on a USB device, right? USB 3, it's gonna be 4.5, that same 5 volts on that same pin, but this time they've upped the amperage for USB 3. They upped it to just short of an amp, right? And then USB Type-C, again, because when you're actually using it as a USB Type-C cable USB connector, the most you can get is 15 watts. And again, 3 amps, we've got 1.5 amp on each side, each voltage lane, each voltage bus. That's how we get to 3 amps, okay? So that's 5 volts, 3 amps, 15 watts. Okay, now, the thing to know about USB power for all the various iterations, USB 2, 3, whether it's on an A cable or a C cable connector, excuse me. When a device connects, it plugs in and it gets USB-C or USB does power in unit loads, right? So it's each USB version has a different spec for what that load is. So for USB 2, a unit load is 100 milliamps, right? For USB 3, it's 150 milliamps. Sorry, forgot. But USB 2 only has 5 total unit loads, so that's your 500 milliamps, right? That's how you get your 500 milliamps. There are 5 unit loads of 100 milliamps each, right? So if I plug in a cable and it draws 3 load and it needs 250 milliamps, right? How much amperage is the host controller gonna give it on a USB 2 port? Right? Because it's only going to do it in unit loads. I don't know if I've made this as clear as I wanted to, but the point is it's only going to give it in unit loads. So if it needs 250 milliamps, it's going to get 3 unit loads, which is 300 milliamps, right? So that's an important thing to understand. So we'll talk a little bit more about that. But before we do, let's spell out some of the others. USB 3 will give you 6 unit loads at 150 milliamps. 6 times 150, that's where you get your 900, right? USB-C, it allows you to have that, but it's still, again, based on that USB 3, it'll give you those 6 unit loads. But here, it ups it to 200, you can do 250 on a USB-C cable. Now that's not the spec, that's just what the cable's capable of, right? Connector is capable of. So 250 milliamps. 250 milliamps times 6, what does that give you?
3 amps.
No. 1.5 amps. But how do we get from 1.5 to 3? 2 lanes. There you go. So I don't have another slide to sort of illustrate this, but I want to dig on it a little bit more and explain. So when you plug in a USB device, say it's a webcam, and you plug that into your laptop, what is actually happening on your device is that it connects on that power pin. There's something connected here. There's a voltage here now. So I'm going to give you 100 milliamps, 1 unit load of power if it's USB-C, 150 milliamps if it's USB 3, or 200. If it's USB 3, it'll give 150, right? Now, and then it will enumerate. So it'll tell the host controller what it is, and we'll talk about this a little bit more later. It'll tell the host controller what it is and how much power it needs to run, to operate. On that 1 unit load of power, it just says, hey, this is what I am and this is what I need, right? And then the host controller, which is your USB chip on your computer, will then supply the necessary power. So what happens if I've got 2 devices already plugged, or 3, let's use this example that I used. Say I have a device and it's 250 milliamps, it requires 250 milliamps to operate. So I plug in 1, how much power is it going to get? This is my initial question. It's going to get 300 milliamps from a USB 3 circuit because it's only got 100, it needs 250, but all it can give is 150 increments, right? So that's 300 milliamps, right? Okay, so I plug in another 250 milliamp load device. How much is it going to get? Nope, 300, right? It needs 300, so it's going to get 2 more loads, so that's where you're going with 4. 2 loads and 2 loads. So we've occupied 4 loads of power. How many loads are left? 2, because USB 3 will only gives you 6, right? 6 loads. So I plug in a third one that's 250 milliamps. Say we're on a 4-port hub here, right? I plug in a third one. It needs 250. How much does it get? 300, right? How much power have we used on a USB 3 port? All of it. What happens if I plug something into that 4th port? Is it going to work?
Error message.
I'm not going to get an error message. It's just not going to work because it can't even pull the power to enumerate. So it's just going to go. You'd be like, why is this not working? And then you disconnect the other one and plug the other one back in. It's like, now it works. Why? Right? That's why. Right? So if it were a USB-C hub, you can get up to 250 milliamp unit loads. You can give 6 250 milliamps. So it would just need 1 load to power that 1 device if it was USB-C, right? So it would work like that.
So doesn't the hubs provide their own power, like a power supply?
Yes, but we're talking about what the host controller on that hub is actually going to do, right? So yes, if you have one that will give it more power, then you can get it, but the host controller is only going to give it so much. So if you plug a passive host hub into a port, then all it's got is what's available on the root host controller, right?
Will the hub take one of those power units? Or?
It will, and we'll talk about that. But yes, you've only got what's available. So when you plug in the host controller, then all you're doing is bringing it back up to 900. So That's all it's going to give you. So even if same deal, if you plug all 4 of those or 3 of those into the host, and then you try and plug in into the hub, and you try and plug in a 4th one, the same thing's going to happen, right? But you will get all 3 plus whatever 3 are on the original hub, because again, they've got all their power that they need back on the original host.
Maybe this is like too much for right now, but why does it work in unit loads and not just like whatever else?
Just how the spec is written, how it works. I mean, I don't know the actual reason why they designed it that way when they were building the engineering in the original release candidate, but that's just how it works. It's not just pulling a limited, it's just how it allocates it. It probably has something to do with how the host controller talks to the processor and how the processor can allocate. Yeah, and also it's a standard thing because you don't really know what processor is, like if I've got an Intel processor or an AMD processor, think back in the mid-90s, right? We don't necessarily know because they're not exactly the same thing. We don't necessarily know, and this creates a standard that they can all rely on. So that's all I want to talk about on power today. We're already halfway through the class here, and I haven't even gotten to the fun stuff. We'll move on to talking just briefly about data. I want to touch on the different transfer types. So there are a bunch of different transfer types, but there are really only 3 types of transfer that we're talking about, or that we're interested in. And all you need to understand here is sort of how they interoperate. So if you've got some issues with some weird data issues or glitches or things like that, this might help you think about them. So that's why I want to talk about it. The first type is called interrupt. So these are your basic, most high priority devices. Think about a mouse. Like you move your mouse on your screen, you expect it to move, or on your table, you expect it to move on your screen. You type something in your keyboard, you expect it to show up in the field prompt, right? Those are your interrupt devices, right? They are going to they're going to interrupt anything else that's going on, but generally speaking, they have a bounded latency, so they're not going to take up a lot of your space. We're talking, again, mostly about HID stuff here, right? But if you're seeing slowdowns on your mouse, like on your screen and something like that, that's probably more of load on your processor and your rendering of your graphics rather than the actual USB connection. So I wouldn't, like if you're getting a slow response, don't try and unplug and replug your mouse. That's probably not your problem. Try closing some programs or something like that. The other kind is isochronous transfers. Isochronous transits, and it's not isosynchronous, it is isochronous. Transfers, these are the ones where we are trying to do a fixed bandwidth, right? But we're going to allow some data loss to try and maintain that because it's real time, right? So this is our webcam, right? And our streaming audio. These are isochronous. So when you're looking at specs of things and it refers to isochronous, you know what it's talking about. It's talking about your AV streams, right? The next type is bulk transfer. That's your file transfer. That's your external hard drives. It will take whatever's left. So if you have an isochronous stream going and you plug in a hard drive and you try and copy something from that device onto your desktop, it's not going to impact that stream because of the way it's enumerated. It can't interrupt that feed, right? So don't think that because you're kill that file transfer, it's interrupting my video call, right? That's not what's happening, right? Because it's a bulk transfer, it will use what's available to it. So if there's only another 330 megs left, it will use 30 megs a second, and it will use that until it's done or until it gets more available, right? So if you kill your video stream, then it will get a bunch more, and it will push more data through. So if you do need that transfer to happen quickly, kill your video, that kind of thing. So why is this relevant? Mostly it's just to make sure you understand what's actually happening. So when you see problems arise or you're thinking about problems that are building your system, your USB system, how to actually put it all together. Like that's what we're trying to do here. Like just keep these things in mind. If you maybe don't plan to put an external hard drive on the same system that you want to do a video webcam or something like that, right? Really quickly, I just want to make sure and touch on it. So USB 2, it is 480 megabits a second, so that's kind of pretty much what you need for your most video stuff. 5 meters or 16 feet, that's the max limit of a cable, right? So if you've got a 25-foot USB cable that you're trying to get across a table from a camera or a keyboard to a PC, it's not going to work, right? Because that's our max limit based on Ohm's law, essentially. That's what's happening here. We can't get the power to power it up. And the data won't propagate through the capacitance of the cable. USB 3, all the various generations of it. And if you've ever wondered, like, there's like 15 different names for these things. Like the USB 3.2 Gen 1, USB 3.2 Gen 1 by 2, USB 3.2 Gen 2 by 1. There's all these kinds of names for it, but it all has to do with the encoding style, and when you see that, it has to do with the encoding, and it has to do with the with how many lanes of data it's actually using. So when you see USB 3.2 Gen 1, that's essentially saying it's going to be using the only one of the high-speed, or it's going to be using a lower encoding rate on one of the differential pairs. So essentially, it's not passing the data as fast. That's why it only goes up to 5 gigs. But notice here the cable length, 9 feet. So that's pretty short. Think about a rack you're trying to build, and you're designing your rack layout. Think about where your USB devices are and where they need to interconnect, right? Because 9 feet, you could probably get where you need to go, but maybe not the top of the rack to the bottom of the rack if you're going to lace it in everywhere. Yeah, question in the back.
So is there any way to like boost that? Is there
Sure,
any
you
way to boost that?
can put an extender on it, but we'll talk about that.
Okay, all right.
But ultimately, no, there's not a way, right? The cable itself can't push the data further than this on the spec, per the spec. So that's, if you want to get 20 gigs, you've got to have a cable that's less than 9 feet, which means you need to put it in your rack in a way that it can be wired up with that cable. Finally, USB 4, that's going to get you up to 40 gigabits, and again, that's because we're using a pretty high encoding rate on all the differential pairs that are available on USB-C today. But notice the length, we're down to 3 feet. So obviously we don't have any USB 4 right now, but think about that's going to be a problem if you're trying to wire a rack. Okay, let's go. So I don't really want to talk about this, but this is essentially, there's a bunch of, like when your device connects, I told you it pulls power and then tells it what it is, tells the host controller what it is. All you need to know is that there's a bunch of different types of enumeration. Generally speaking, most of your devices are going to enumerate as a 10H. Notice a 9H is a hub. So why does that matter? Well, maybe we'll look at that if we get a chance later. But it's more just knowing that it's there. They enumerate, and how they enumerate tells the host controller and the CPU what to do with it. So when it enumerates as a 10H, that's how you get the alert. Oh, hey, I've got this webcam now, right? Okay. So originally, nobody really knew what we were talking about. How many people have you even heard this term tiers before when we talk about USB? Anybody? You have. Okay, great. We are not talking about the tears that we cry when we deal with USB. We're talking about logical hops between a device and a host controller, right? So let's say we have a customer, a client. We got to do a design for a customer that has a laptop, and the inside of your laptop there is a host controller. Excuse me, sorry, got ahead of myself. There is a host controller. That host controller, if you ever look at your device manager and you look at your USB-C, that's what you're seeing. That host controller has a root hub inside. So inside, connected to every host controller is a hub. The root hub is the one that's actually on your laptop and is actually talking to the CPU, right? So say we've got a webcam and we want to connect that, right? Okay, all's good, right? We've got essentially, so you've designed this, and then your guys go out to the site and they say, oh, actually, this person that wants us to do this, he actually wants it over there instead, right? Not right here. So what do? What would all of us do? What would we do in your scenario? We just throw an extender on there, right? Why is this not working? There we go. There's our extender, right? So we just throw an extender in there, right? Now, but then say, oh, actually, no, we need to move it, and now it needs to be over here. And well, we've already designed in that extender. My example was supposed to say, but he wants it to be 15 feet away. So what do? You put more than 15 feet. So what do? You put in an extender, right? But then you show up to site, and he says, actually, no, it needs to be over there, and it's 25 feet away. Well, your extender doesn't work anymore, right? So now, okay, but we've already got the space. Let's just throw another extender in, right? So what is to stop me from wrapping the whole world in extenders, right? Why can't I do that?
Because it can only hop 7 times.
That's right, because there are only 7 tiers, right? So when we look at this system, I went the wrong way. When we look at this system here, I'm all mixed up in my thing. What we have here is this is our first tier. That's our host. And this is our last tier. This is our function. So here we have a one host, one tier. Here's our second tier, and here's our third tier. So this is a 3-tiered system, right? So, but, that handles most things, right? So the problem here, anybody got a guess? Nobody got a guess?
There might be multiple tiers in a single hub.
That's right. There might be multiple tiers in a single device, right? So your laptop has a host controller. Anybody seen a laptop with more than 4 ports on it? You have. I used to have one. Most of you, if you're designers, you've probably been given a pretty beefy laptop at some point, and it's probably had more than 3 ports on it, right? That's because there is a stacked, my thing's all out of order here. It's because there is a stacked hub inside of your laptop, right? Anybody know how many ports are allowed to be on a single host controller? You do, but let's see if anybody else does. No? You do. In the back. 4. Right, obviously, because every hub you've ever seen has 4 ports, right? So the spec does require that for every host controller, there are only 4 ports, right? So this here is it representing our host controller, and this is representing our ports, right? Every one only has 4 ports, right? Anybody ever seen a 7-port hub, right? Anybody ever seen a 16-port hub? Anybody ever seen an 8-port hub? Why not? We go 4, 7, 16? How's that work, right? Doesn't work, right? Doesn't make sense. Well, that's because inside of the 7-port hub, we've actually got a stacked hub, and that secondary hub is connected to secondary host here is connected to the first port on the primary host, right? That's also happening in your laptop that has more than 4 ports, right? Now, and just for grins, here's our 16-port switch. It's essentially got 4 hubs, but they're all hanging off a secondary. So anytime you use a 16-port switch or hub, you're essentially adding 2 tiers to your system. So we take our system that we described earlier, and instead of an extender, we design in, because we know he's going to want to have a flash drive, he's going to want to have he's going to want to have a headset, he's going to want to have other things, and it's more than 4. So we say, okay, well, let's just put in a 7-port hub. Now, the market and industry has gotten smart enough, you can't really buy a 7-port hub right now because they understand the problem. But just for grins, let's talk about this. We put in a 7-port hub, right? But then you find out, oh, hey, it's still that same scenario. We need to extend it. So how many tiers are we at now? If we plug into the first port of that 7-port hub, we're at 1, 2, 3, 4, right? But if we plug into the last 4, then we're at 1, 2, 3, 4, 5. And you can't know, you can find out, but you can't know, or your users aren't going to know. They're not going to understand. They see 7 ports, right? They're like, they're all the same to me. Why is this one work and this one doesn't, right? So they can't know that, hey, I'm at a 5-port system now, right? Just can't know. So let's say you design this system though, because 5 ports is still less than 7, we're good, right? But what happens when you show up to site and he's like, oh no, I've got a dock that I plug into, right? Well, now we're at 6, right? But what happens if that previous example I had where he's got a secondary hub inside of his laptop, we're at 7, right? Will it work? Should. But who knows how many, we've made some assumptions that our extender only has 1 host controller. Most extenders actually have a host controller in the local side and a host controller on the receiver side. So that would be 2. So if we had one of those, this would be 1, 2, 3, 4, 5, 6, 7, right? And then if he was connected to a different port, we're done. We don't work, right? I did this myself at one point when I was designing a system for a San Francisco office where, it would work on some ports and not on others, right? And what I had done is I had done a webcam extended to a hub in a rack, and then the hub in the rack was extended out to a hub in the table out front. And I screwed that up, and that was one of the reasons I left that company, because I was like, what the hell am I doing, right? And I learned a lot more about it. Now I get to stand up here and teach you guys about it.
If you don't have a switcher in the system, USB switcher, that might be, who knows?
Yeah, exactly. Yeah, the whole point is there's no way to know on the surface, right, how to do it. Now, I've had conversations with our product team at Crestron being like, Why don't we publish the number of tiers in our specifications? That should be in there. It's the most important thing, especially as we are pushing USB as a platform right now. But we're working on that, and I'm trying to make some progress. Stay tuned.
Can I ask a question? Can your computer have more than one host controller that talks directly to the
It can.
motherboard?
It can.
Add an extra-
You might also have, if you do only see 3 ports on your laptop, it's possible that you might have integrated USB devices on your laptop. That's a thing that happens too. So you might have 3 ports on your laptop, but the reason for that is because one of those ports is occupied by some other device, say your webcam. That happens sometimes, depending on your manufacturer. My Dell doesn't do that, but it's actually integrated, I think, on the motherboard in another way. But one thing, again, you just never know, is that they might have 3 devices that are integrated into the USB port inside your laptop. In that scenario, they give you that 4th one, but you need more than one USB port, so they put a hub on it, and even though you only have 3 ports available on your laptop, it's actually going through a hub, right? Through a secondary host controller, right? So it's just like, this is very, like, it seems, I'm doing it with very colorful, bright images, but you can understand this is the stuff that will screw you, right? When you're trying, because you think it all's gonna work, and you get out there and you get sidelined, right? And hung up on all these issues. So these are things to think about. So this is a tool you can use. It's more for troubleshooting. You can't use it on the design side, but for those of you not familiar, there's a tool out there called USB Device Tree Viewer. Anybody heard of this or used it? Anybody used it before? Nobody familiar with it? That QR code will get you to it. It's by a guy in Germany. His name's Uwe Sieber. I'm not endorsing it. It's not my product. It's not Crestron's product, but highly recommend it. I'm using it. It looks like this, and I'll blow it up a bit for you. Oh, I'll leave that for a few more seconds for you guys still grabbing it. Blowing it up, this is that menu on the left. So essentially it's an accordion style list. This is my laptop, and I can pull this up for you if you want to see it. We can step outside and look at it later, since we're almost at the end of our time. But essentially, here's my host controller up here, right? There's my root hub, right? And what I've done is I've actually taken I had a NUX or a USB wall plate device that we sell with an NVX and a camera connected to the NVX. This was my demo that I did. Camera connected to NVX and then going into the network, and then I had a host port on a gangable plate connected to my laptop going to the network, right? So I'm talking over, sending USB over the network. That's what this is. Like, you actually make a connection between the host and the NVX. That is this system. And there's my webcam connected to this hub, connected to this hub, connected to this hub on my host, right? So it was a very simple system: webcam, host or receiver, transmitter, laptop. That's all I did. But what you've got here is accordion style, and it's showing you all the ports on the root hub and what's occupying them. So this PixArt HIB HP USB optical mouse, this was a mouse I was using at the time. SunPlus Innovation integrated webcam. So this is the webcam on my device. You see it's integrated into USB. I was wrong, it actually is integrated onto my host. Here it is on port 4 of this root hub, right? Or port 6 on this root hub, right? Now, why do we have more than 4 ports on a hub here? Well, they're virtual ports, right? So it's like when you plug it in, the host controller, if it's capable of doing this, will say, okay, I need this port to be a USB 2 port and this port to be USB 3. But remember, those lanes are on there on all the switches. So what it's doing is, if it's getting data on just the USB 2 lane, then it says it's going to put you in one of the virtual hubs on that port, or virtual ports on that hub, right? So it's still only 4 ports. But anyway, the point is you can see kind of how many tiers it goes, and then that menu on the right, this right here is actually the interesting thing. This shows you our tiers, right? So we can see here's our host, port is 1, and then 3, that's port 3, right? Port 1, that's port 1, and then our device is there on port 1 of that device, of that hub, right? So that is our tier chain, right? So click on any finished device and it'll pull up this menu for you. It also does show you your USB version that you're doing. So mine is USB 2. And then it does show your demanded current, so how many unit loads of power you're getting. It also does tell you the enumeration. I can't remember where it is, but it does tell you, it might not be in the snip, but it does tell you how it's enumerated. So that kind of is the end of where I'm going to stop today. And look at that, just on time. I do have a whole bunch more content in here, but that's all more Crestron related stuff. There's a few other things I want to talk about that didn't really fit into anywhere. Clocking, anybody ever heard of clocking as it relates to USB? So can you connect two 6-foot USB cables together and have them, or two 15-foot USB cables, what's going to happen? Not going to work, right? But if you were able to reclock it, essentially that would reestablish the communication. So if you're able to put a reclocker in, that's kind of how that would work. Like our USB extender cable, that will reclock. That's part of how it does it, because it's a female connector on the end here, right? So you could connect a 15-foot cable to that, and then it would reclock because it's a powered device, active cable, right? And it'll reclock it, and that's how you get the full length of the cable, right?
Does that count as a hot?
No, it does not, because it's just reclocking it. It's not actually a host controller in there. So this is not spelled out in the specs, but it's something I want you guys to know. I tell people this is the default cable they should use when they're doing USB extension, because you can get up to 150 feet. It's a fiber optical cable. I'm getting into stuff I'm not supposed to really talk about here, but I'm happy to discuss it at our table and things like that. We got a bunch of other USB solutions, and I can help you think through some of those. Also, if you do need to, I'll skip to the very end here. Actually, yeah, let me just go here. I'll skip to the end, and I'll just pull this up. Yeah. So these are just some QR codes for you guys to grab. This is the general USB.org, essentially. You'll find a lot of the specs, and all the information that I'm talking about today is detailed in there in much greater detail than I have, although Wikipedia is probably more friendly for you, but that's where you can find the actual spec. Here's a link to that device tree viewer. Our design database, I throw that up there because it's worth mentioning about, like, if you do have designs that need USB, you can always look at our design database to find designs. And you can always, if you're not familiar with sales support, Crestron Sales Support Services or tech sales at crestron.com, you can always submit a design to them and have them review it. And they'll give you some feedback, be like, oh, that might be too many ports, or I wouldn't do it this way, that kind of thing. They'll help you with that. And then lastly, again, I told you at the top, this course is basically a hacked down version of the presentation that Ken did at Masters last year in Barcelona. This link will get you there. But you do need to be logged in. And again, if you don't have an account, talk to Dawn. Right? Okay. We're at time, but I'm happy to keep talking. What do you guys want to hear about? What do you want to talk about? If you don't want to talk, you can leave. Yeah, go ahead. Jordan.
The extension cables usually run the one that you're showing at the end.
The extension cable, you mean in terms of cost?
Yeah.
I believe it's $800 for the 150 foot. It's plenum rated. It's plenum rated. It passes standards for tensile strength. But if you are hiring an integrator to pull it for you, make sure they have experience with fiber pulls. The cable is very stiff. It is plenum rated, so it has a stiff jacket. So it'll pull through a conduit, but you want to make sure that conduit has at least a 70 millimeter bend radius to fit the head in.
A-style connection or C?
It's A to A, but A female to A male. So you do need a jumper cable on the end. So like if you've got a webcam here and you're going to use that thing, you're going to connect the camera into the female end with either a jumper cable or the built-in cable, and then plug the A male end to your device on the other side. And no hubs. There's no additional host controllers, so that would be a one-to-one tier. Yeah, in the back.
When you say it resets the clocking, what does that mean?
Well, it doesn't reclock it. It doesn't reset the clock. Reclocking is just the term that we use to describe that it's actually reestablishing the link. So it's establishing a link between a host controller. So if we go back to,
Because it's a fiber cable, so it's not, the cable specifications aren't the same as just standard copper cable, right? So it doesn't need to worry about the distance as much as what you're saying.
right, but the point is that it won't, like, say you plugged in a 20-foot USB cable into the hybrid cable, it's not going to work, right? Because the distance from where it gets clocked at the female end of that cable and the host is too far, the information's not getting there, right? But when you use a right size cable, it works because it's going to reclock it. Now, it works, that explanation makes more sense when you think about it in terms of a pure category rated extender, something more like this thing, right? Which is going to have you're going to put a category cable between these two devices, right? And then it's going to connect to your laptop on this side and your peripherals will be here, right? So how long can the cable be that connects here be, and how long can this cable be?
I assume you can put 15 or 9 or whatever on both sides.
Yeah, whatever the standard spec you're trying to use is, that's right. Why does it do that? Because it's being reclocked at the,
So they're going to get you visual connections.
right. You don't, like, one of the questions that I had is, like, does the length of this cable and the length of this cable have to be less than the spec? And the answer is no. Each one can be the full spec, and that's because of reclocking. And pretty much every extender is going to do that, right? It's going to reclock it because it has to. Essentially, anytime you're touching a host control, you're getting reclocked, right? And that's why it's interesting that our hybrid cable reclocks it without a host controller. So there's a question here, sort of right in front of this gentleman. Yeah, go ahead.
Just curiosity, is USB just bits like RS-485, or is it modulated somehow?
Well, that's a good question, but I don't know the answer. If you come get my email or shoot me that question in an email, I will find out for you though. That's a good question. I'm assuming it is modulated in some way. Because I mean, that's a lot of data.
Is that fiber cable you have carrying, you got some copper in it too to carry the
It does.
power for the,
Yeah.
the device?
It does. It's a hybrid cable, so it's got optical and it basically it's connected to the voltage bus, pin 4, so that
Figured
it,
it kinda had to be, so.
yep, that's how it's powering. It's
Is it
lighting up the
voltage
LED.
at the end to power the device?
It
Or-
will give you that voltage on the end. Whether it will power it or not, I can't tell you, or I won't commit. I have seen one of my, Joe down in Southern California, he swears it'll power his Hudley. I've never gotten that to work. There's one other thing I mentioned the Hudley, and that reminds me of one other thing. Anybody know any manufacturer that specifies the bandwidth needed to carry their video on a camera, on a webcam? Anybody know of anybody that does that? No? Why do you think that might be? I don't know, but I have a strong suspicion, but I don't have an answer. But why do you think that might be? My guess is because you don't really need USB 3. I think the reason why USB 3 cameras are USB 3 is because of the power, not the data. Because they need more power, because most USB 3 cameras, they're the ones with all the processing in it, right? The framing, all that various stuff, the people counting that's going to happen in them. I think they need USB 3 for the power, not for the video bandwidth. So just something to think as you're thinking about your design. Also, just as a note on that, like, do you really need a USB 3 camera if you're going to plug into Teams? No, because Teams is going to crush it all down to 720 anyway. Now, will that always be the case? No, but today it is. So, anyway, it's an interesting topic. I hope this has been useful for you guys. I definitely am not trying to keep you. Feel free to get up and walk out if you want. But again, like I said, I'll be at the counter there if you want to go there until 5, and I'll be back tomorrow. If you come up with something tonight while you're tossing and turning in bed, I'm happy to talk about it. Thanks, guys.